So let's do problem number 45 on page 195. Let me read the problem. It says, two spherical balls are placed so that their centers are 2.6 meters apart. The force between the two balls is 2.75 times 10 to the negative 12 newtons. What is the mass of each ball if one ball is twice the mass of the other ball? So I've laid that out here. Here's one of the spherical balls. This other one has twice the mass. So I just call this M, and I call this 2M. And we want to find the mass of this. And if we find the mass of this, we'll find the mass of this other one. And the force of gravity between them is given to be 2.75 times 10 to the 12 newtons. And they are 2.6 meters apart. So if we have this, we know that the force of gravity between two massive objects is the gravitational constant times m1 times m2 over r squared. This is the basic equation. Now we want to apply what we know to this. So we know that force of gravity is equal to g. Now m1, we'll call this m1. m1 is just 2m. And that's how this one's kind of tricky. And then what is m2? Well, we're just calling that m over r squared. And now, well, if we simplify this, this is going to be g times 2, and m times m is m squared over r squared. So now we can solve for m. We want to solve for m. So m is going to be equal to, well, we've got the force of gravity. We've got r squared. Then we're going to divide by g and divide by 2. And now we've got m squared, so we'll take the square root of all that. So I just solved for m. And now everything is numbers. Long, annoying numbers, yes, but just numbers. The force of gravity is given to be 2.75 times 10 to the 12, negative 12 newtons. If that was positive 12 newtons, oh, these two things would have to be so massive they're like black holes or something. But it's negative 12 newtons, or almost 3 trillionths of a newton, very tiny force. And this is r squared, so 2.6 meters squared. Divide by 2, I'll put the 2 out front, and then g is 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. And let's take a look at the units first. Look at the Newton cancels the Newton. We have a meter squared cancels the meter squared. We have a 1 over kilogram squared. Reciprocate, multiply, take the square root, and yes, indeed, we get blank kilograms. And by checking the units first, that's always a good thing to do, because then you know you're probably doing it right. If the units cancel out the way they should, you're in good shape. So now we just have to plug in all these values. So let's go. Let's turn my calculator on. So first I'm going to take the square root on my calculator. And don't be afraid to use lots of parentheses. So parentheses, 2.75 times 10 to the negative 12 times 2.6 squared, okay, divided by 2. Let's back up. I'm going to put another parentheses. 2 times 6.67 times 10 to the negative 11, close parentheses, equals. and I get 0.373 kilograms. The hardest part of this is the calculator work. So one of the things, if you go times, if you go divide by 6.67 and then you go times 10 to the thing, well, the times 10 to the whatever you're doing sometimes is not in the denominator anymore, it's in the numerator, and now you're off by a factor of gazillions. Okay, so make sure that you are very, very, very careful about the way you enter these in. Now, 2m, you just take that answer times 2, and you get 0.747 kilograms. And that's the other mass. So just, here's the mass, here's twice the mass. And that is how you do problem 45. That is all.